jump into chapter 4.1 and look at what is a mineral. By the end of this section, you should be able to explain the 5 characteristics of a mineral, be familiar with the properties of a mineral, be able to explain how minerals form, and then also identify minerals based on these properties. And we'll do a lab with this as well. So a mineral is defined by 5 characteristics. It's naturally occurring, it's inorganic, it's solid, it has a crystal structure, and a definite composition. So minerals that are naturally occurring mean that it happens in nature, so they're not man-made, so it's something that you can find on this planet. If it's inorganic, it means it's not alive and it never was. So for example, salt is a mineral, whereas coal and sugar are not because they're carbon-based, which means that they came from once living things. These minerals must also have a crystal structure, so that means that at the atomic level there has to be some kind of repeating pattern. They must also be solid, meaning not a liquid or a gas, so they have some definite shape and they take up a specific area or volume. And the last characteristic that these minerals need to have is a definite composition, so it has to be made of elements or some kind of combination of elements that gives it a unique chemical composition. So there's over 3,000 minerals on Earth, although only about 30 are common, and about 8 to 10 of those are what make up most of the crust. So some of these minerals form from magma. So magma is the molten material that we find below Earth's surface. What happens is, because the magma is hot, it's less dense, and therefore it rises and cools. As this magma cools closer to the surface, it's going to start to crystallize, meaning these crystals are going to start to grow or develop as the magma solidifies. The elements that are in the magma is what determines the minerals that form as a result. And then also how fast or slow it cools determines the crystal size. So for example, if these minerals cool really quickly, then those crystals won't have a chance to develop, and you're going to have a small crystal. Whereas if you give that magma a long period of time to cool, those crystals are going to have a long chance to grow and develop, and therefore will be a lot bigger. So minerals also form from a solution. So minerals are dissolved in water. For example, you have salt that's dissolved in water, if you think of the oceans. When minerals are dissolved in a liquid and can no longer hold any more of that mineral, that solution is said to be saturated. So what happens is if you try to add more salt to something like salt water that's already saturated, it then becomes a supersaturated solution. When this happens, you get crystals that start to form. But you can also get this crystallization to occur when you have evaporation. So for example, if you go to the beach, if you've ever gone swimming in the ocean, and then you get out and you air dry, and then you kind of feel crusty and not really itchy, but you feel those little salt crystals on you. That's because the water evaporated off and it literally left those salt crystals behind. So each mineral has its own specific set of properties that make it unique from one mineral to the next. So you have the characteristics that define a mineral. So it's got to be solid, inorganic, have a definite composition, a crystal structure, and then also, which one am I missing? Must be naturally occurring. Those are your characteristics, but the properties, on the other hand, are what make a mineral unique. Geologists can test these different properties in order to determine what the mineral is specifically. So for example, if we look at these two minerals, you'll see they're very different in their properties. So the first of which is a crystal structure. So that's the shape that it forms. So what shape do these crystals come out to be? You get salt to form perfect cubes, whereas you get quartz to form those pointed edges. So based on that crystal structure, we can tell them apart by looks. And then you have luster. And luster describes how shiny it is, essentially, how much it reflects light. So if it's metallic, then it's usually going to be made of some type of metal, whereas if it has a glassy luster, then it's going to be more of a clear mineral like quartz. Other terms that you might hear are earthy, waxy, and pearly. So if we take a look Our luster of quartz here is glassy, and if we take a look at this mineral, it is very shiny. It's like a metal, therefore it's metallic. And then we have hardness. So hardness is a mineral's ability to resist scratching. So this is rated on a scale from 1 to 10, with 1 being the softest, which is talc, and 10 being the hardest, which is diamond. For reference, our fingernails are a 2 on the hardness scale. If we take a look, you can see there's our talc at 1, and then as you go down this chart towards 10, the minerals increase in hardness. And then we have everyone's favorite, cleavage. So cleavage and fracture describe how a mineral breaks apart. A mineral that splits evenly along a flat surface is called cleavage. Whereas if a mineral breaks into random pieces, there's really no rhyme or reason why it's breaking apart. This would be fracture. But cleavage is breaking along a flat, even surface. So if we take a look at this picture, this would be an example of cleavage. Whereas something like this, if you were to take a hammer and hit it, it would fracture, it would break into smaller pieces. And then we have streak. So streak is essentially the color of the mineral's powder. So if you take the mineral and you scratch it along a porcelain plate, that streak is going to leave behind some color. However, not all instances you're going to have the streak color be the same color as the mineral. For example, pyrite, it's a gold color, fool's gold, but its streak is a darker gray or black. So streak is just the color of its powder when scratched or streaked across a porcelain plate. Then we have color, and color is the most obvious one to us. It's just simply, what color is it? However, it's not necessarily the best way to identify a mineral, and we'll talk about why in class tomorrow. There are some other properties that we can look at to identify the mineral, one of which is fluorescence. So does it glow under a black light? And some of them do, and I'll show you a couple of these examples as well. Is it magnetic? So if you actually put a magnet to it, will it be attracted? Is it radioactive? Does it give off radiation? And then also, does it react with acids? So we'll use hydrochloric acid in class and we'll drop it on some minerals and see, is it going to bubble or dissolve the mineral when we do so? In addition, you have texture, and texture is just how the mineral feels to the touch. So for example, it could be smooth, rough, jagged, greasy, soapy. These are all terms that we'll use to define its texture. And last but not least, its density. And remember, density is mass divided by volume, but in this case, density shows us how tightly packed these atoms are at the atomic level. So no matter what size you have of mineral, whether you have a little small sample or a giant boulder or even a house size, the density is not going to change. So you can use that to determine one mineral from another. For example, gold and pyrite, fool's gold, you can look at the density to determine which is true gold. Now that we've gone through the notes, you should now be able to explain those 5 characteristics of a mineral. You should know those different properties that we just talked about. You should be able to explain how minerals form, as well as in the next couple days we're going to be identifying minerals based on these properties. Until next time, see you later.